everyone. Today I'm going to talk about linting and how to treat your test code as production code. First, some information about myself. I've been in the software testing industry for over 12 years. That's my whole career. I focus on implementing tests and test automation strategies and designing test architecture at different organizations. I specialize in web, mobile, and API testing. And I'm based in the Netherlands. Here's some contact information about myself, so don't hesitate if you have any questions to contact me. So what is linting? So linting is the process of running a program that analyzes code for potential errors. So it's looking for undesired pieces of code. It's also known as static code analysis. So it's not running your code. It actually takes your source code, checks it for all the undesired pieces of code you don't want in there. Wikipedia has a nice description. It says, a lint or a linter is a tool that analyzes source code to flag programming errors, bugs, stylistic errors, and suspicious constructs. So again, all the undesired things in your code you want to get rid of, or you want to be notified about it, a linter can help you with that. The term is actually derived from sheep. I looked it up. Don't ask me why it was derived from that, but the term was derived from that. It was about removing undesired bits and flaws from sheep's wool. So why do we lint? I mean, why do we want static code analysis? Code is opinionated, right? I mean, if you open up some code base you have never seen before, how often do you think, wow, this is awesome, I'm not going to do anything about it, right? Most of the time people are like, oh, I'm going to refactor this, or this can be better, or I don't like this formatting, I don't like the indentation. So a lot of things is about code style. So you have people saying, I have my own coding style, or in the JavaScript world, I dislike semicolons at the end of the line. It's not right or wrong, it's opinionated. I see on Twitter huge threads about, hey, the opening curly brace should be on the new line or not, and people are, well, they can talk long about it. Again, not right or wrong, it's opinionated. And when you share code in a large organization, well, it doesn't even have to be a large organization. If you collaborate together, you have to agree on some kind of coding style. So on GitHub, there's a nice project called Popular Convention. And what this project does is it scans millions of commits on GitHub, so open source code, and checks for popular code conventions. In this talk, I'm only going to focus on Java and JavaScript because I'm most familiar with that. For other programming languages, you can find similar examples. So let's check this one out. So in Java, you have the space and the tab. And the difference here is that the bottom one, the tab, is actually the tab character. So if you press the tab key and you go back with the left arrow, it actually jumps back to the beginning of the line. And the one on top is actually, if you press the tab, it actually adds like 2 or 4 spaces or whatever you like. Who here writes Java code? A decent amount. Who writes JavaScript code? Well, it's or the same people, or it's like 50-50. So who uses the spaces? So when you press the tab, that it jumps a couple of spaces. Who uses the tab character? All right. So if you look at some stats this is based on 3 million commits on GitHub. This Java. So you see a 66% preference for the space and the tab. It gives them some insight of what people are committing. Not right or wrong, but it gives some insight. Let's do another one, the famous curly brace. Right? On the same line on the top, on the new line. Who uses the curly brace on the new line? All right? So we can get up. So it's like 58%. Use it on the same line, so with 1 space, 37% and on a new line. Line length, big thing as well. I've seen discussions or I've been participating in discussion about how long the line length should be, how many characters, like from 100 or 120, 80. So if you look at GitHub, it's actually surprisingly concise, which I also personally like, to keep the line length concise, because then you don't have to scroll, right? It's a practical reason for me. JavaScript, same thing. So you saw here on Java, you saw the 66-33 difference. In JavaScript, you see an 80% preference for the spaces. Here you see a function name, and then the parentheses. On the bottom one, you see a space between it, and on top, you don't see it. Yeah, you see 67% no space. And single double quotes. Who actually uses double quotes in JavaScript? There are a couple. This was a very surprising number, actually, for me to see, because in practice, I usually see the single quotes for JavaScript code, and here's almost 50-50. So why do we lint? Code convention standardization, right? Which also increases maintainability, readability. But what a linter can also do is not only check the formatting, if indentation is all great, but also find potential errors, like, oh, this piece of code might never work, or this is instructed in such complex way, I'm not sure if it's going to work. So it can actually do some pre-code reviewing for you. So finding syntax errors, bugs, and this is all without executing the actual code, right? And this is a very common graph, I think, about fixing bugs in which phase. So on the bottom, you see the design, development, and production phase. So if you fix a bug in production, it costs way more than when you fix it, right, when you're writing the code or when you're designing it. Well, that's all great, but what does it mean for test code, right? Well, actually, all of the above. It's the same. It's software. It's source code. But to be more concrete, if you look at WebDrive test code, it can contribute to less flaky test, because it can scan for, you're using a bad locator, or this might not work. Hard weights, like use explicit weights. It can help you in improving the code while you're writing it. Or if you really like the page object model, you could write a linting rule that really scans for that, like, hey, are you following the page object model? The one I find really important myself is talking the same language with developers. So how often did a developer that you wanted help from did want to help you, but when he opened up the test code, the base is like, oh man, all comments everywhere, curly braces all over the place. I'm not sure if I can help out before resolving all these issues, right? So you lose a lot of time in these endless discussions instead of solving the problem or implementing some complex logic together. And in continuous integration and continuous delivery world, we require rapid feedback, right? And for test code, while you're writing the code, and get instant feedback, well, that's as fast as you can get. So if you plot the same graph in the previous slide, the production phase, and for test code, it's actually running the test, whether it's in the pipeline or when you're just running it manually, that is the production for the test code. So when you have to solve a problem, like a flaky test or a test that fails in this running test phase, it can cost way more than when you are, you're typing in the test code, like, okay, I'm going to use this locator strategy that might not be very robust. So how does it work? There's a very simplified graph. So you take the source code, and the linter analyzes it. So it breaks every statement down into a so-called abstract syntax tree. So it's a node tree of all your statements. And then you have a rule set like, indentations, code conventions, or like, test should contain assertion, right? Simple rules. Well, I've seen many tests without assertions in practice, which is always surprising to me. hard weights, locator strategy, stuff like that. So you have a rule set, right? And the things that you want to check in your code. So you have two things, the source and the rules, and then checks it and then gives you back the result. And this goes really fast. So how does it work in your workflow? So you can get instant feedback in your code editor or IDE. You can run it from the command line, which enables you to integrate it in a CI pipeline, right? So when we're talking about formatting and code style, there are many things that can help you out here. Again, I'm going to only focus on JavaScript and Java, and I'm highlighting two, I think, most popular tools here, linting tools. So for JavaScript, ESLint, and Java check style. And on bottom, you see these organizations that have provided their code style, which you can just find online. So for JavaScript, the Airbnb, Google, and Standard.js, I think those are the most popular ones. There are more organizations providing this, but these are, in my experience, the most used. For Java, again, Google, Twitter, Java itself, and Mozilla. So let's do a comparison. So for JavaScript, so what these code styles have in common is like tabs are two spaces. They prefer two spaces. Single quotes, they prefer cons over var. No trading spaces. And you do see some differences here, like the semicolon at the end of the line. Standard.js say, well, no, we don't need that. And Airbnb and Go say, well, I think that's a good practice. Same thing for trading commas. There are more differences. That's just the ones I found like surprising or caught my eye. If you look at the Java one, what they have in common, the first letter uppercase for class names, camel case for method and variable names, all lowercase package names, and all caps are final static constants. Here you see some differences in the tabs, right? 4 spaces or 2 spaces. Line length, I like the Mozilla one saying, well, it's appropriate judgment. So again, there are more differences, but yeah, usually you pick one that fits your organization, and the thing that you can do is customize certain rules like indentations or line length for your preference. So let's take a look at that. Here I have a small test project, so let me show you that it's just containing one test. I'm running a test now. It will open up a web page which has a login screen, login, and assert that you're actually logged in, right? So I started with the Java one. So let me switch to a branch where I have some check style issues. So here, this is the test, right? I visit the login page, I log in, and do some assertions. On this branch, I created this little issue here that I flipped the static imports here. So the Google check style, which I'm using here, prefers to have the import on top. So you see it while you're writing this, you get the feedback. Another one, I created this little if then else statement without braces, so it will say, hey, you must use braces. Let's see. And here, if you have a empty catch block, it will help you like, hey, you should do something there instead of doing nothing. Here I also have the check style plugin in IntelliJ, so you get the same feedback right in a list. And you can also run it from the command line. Here we go. And then you get the same feedback, but then on the command line, and this build will fail if you can integrate it in your pipeline. And let's look at the JavaScript one. So switch to a other branch. Yeah. Open up this VS Code. So here's the configuration. So here I'm not using the Google one for JavaScript. I'm using the Airbnb code style. So this is the ESLint configuration. And I'm not looking at the right one. This is configuration. So just the Airbnb code style. And here, for example, I have a variable that is not used. Here I have a template string expression that I'm not doing correctly, so you probably want to do this. And then, as you can see, the issues go away. Another example here, I'm returning an assignment in a method that should never be the case. Or here, a getter without returning anything, right? Or a small thing here, like a block must not be padded by blank lines. So it starts with a blank line right underneath. That should not be the case. Or if you have a simple object with a duplicate key, it will recognize it. Right? Let's look at the ESLint configuration. So here you see some rules that I have overwritten. Right? If you remember the slide about the Airbnb one, they prefer 2 spaces for indentation. So if I disable this, then it's back to 2 spaces. So then it actually say, hey, this has a wrong indentation. And another one here, command angle. So that's here's an example that here I don't have a trailing comma, so it says missing trailing comma, so I can solve it by doing that. Yep, so let's go back to the presentation. So what else is out there? SonarQube, obviously. SonarQube is an open source platform developed by Sonar Source for continuous inspection. And the nice thing about this is that what the examples I just gave is very language specific. And SonarQube is supporting more than 25 languages, and it provides some kind of dashboard. And it goes further than only formatting, so not only the indentation, but also looking for potential errors. And you have a plugin for your IDE called SonarLint, where you have instant feedback. So it's a bit more verbose, and you need a SonarQube server where your results need to be pushed to. And you're like, well, great stuff, right? You've seen all these linting rules, and it's like, well, this is all for application code. I'm writing test code, so what is this going to help me? Well, of course, you can have the same code style, but what about the WebDriver test code? So I've been playing around with SonarQube. And the reason for me creating this plugin is because for several clients, I need to analyze a lot of code bases, so test code, WebDriver test code. And I didn't want to do it all manually, like bad locators, hard ways. I just want a program to do that for me because I'm lazy, so programs can help me doing that. So I created a Sonar WebDriver plugin. You can install it from the official marketplace from SonarQube. So it has some couple of rules on, bad locators, things that are recommended, assertions, a lot of things about weights. Again, this is a bit opinionated, but you can set the priority different, like, oh, I don't see this as an error or a bug. I see this as a notification, like information. You can customize it in SonarQube as you like. And then there's someone else out there, which I contacted, which is Alexander. He created a ESLint protractor plugin with quite some extensive rules. And the nice thing about this plugin is it not only covers the standard WebDriver good practices, but also covers the protractor API, like the locator strategies, like the by model, all the Angular stuff. So it has a bit more specific rules for protractor. So let's take a look. So let me switch to a different branch. Sonar. I'll start with the Java again. So here I'm showing you the sonar lint. So here I added some locators here. So it seems like because of all those slashes, hey, looks like it's quite tied to the page layout, right? The tree, so it follows the tree. That is something you might not want to do for robustness of tests. Same thing for CSS selector. And here, like, tag name is not really recommended. But again, if in your case you really feel like tag name is a really good locator strategy, you can say, OK, I'm going to disable this, or I just find this as a information notification. So here I have hard sleep, so it will scan that as well. And here I have an assertion in a non-test class. This is a page object that should not contain an assertion. So that's pretty nice. The disadvantage of SonarLint, one more thing I want to show you. Here I'm using the SonarLint plugin in IntelliJ, where you have the same feedback in a list, and if you click on it, it will show you some documentation per rule with some code examples. Well, the disadvantage of SonarLint is only scans the main sources, so in this case, the page objects, and not the test sources here, where I also added some issues here. As you can see, they're not highlighted. But like I said, SonarCube works with a server, and then the code gets pushed to it, and then you can get your test sources scanned. So I have it running here locally, SonarCube. So I just want to show you the official marketplace. So here's the Sonar WebDriver plugin, where you can just install it. So what I did is actually scan this project, my WebDriver Playground project. And then you have this nice dashboard about all these bugs and stuff. And you see here 8 code smells. So here you see all the same list as we saw in IntelliJ. So when you click on one, it jumps to the source code and then highlights it again. And again, if you click on it, you can get the documentation, like here, with some code examples. Well, the thing was the test sources. So here I did scan the test sources right here. So here you see, hey, avoid using explicit weights in test classes, or don't use WebDriver commands in test classes. On my GitHub page of the plugin, I explained how to scan what main and test sources at the same time or separately. It's recommended to scan them separately, because if you scan them together, the test sources are actually seen as application code, which should contain or have test coverage, right? So I recommend to scan it separately, but if you just want to check everything in your project quickly, you can scan them both, just like I did here. And then we have the ESLint plugin for Protractor from Alexander. On his GitHub page, you see quite an extensive list of different rules, but also some very specific Protractor API rules. So let's take a look at that. Let me switch to a branch. So actually I have the same project now. Well, before, when I showed you the Airbnb code style, I showed you a setup with WebDriver IO. So I actually created the same thing, but then with Protractor, because the Protractor ESLint plugin is only for Protractor. So if you look at the ESLint configuration, the only thing that is added is this Protractor plugin. ESLint plugin. The rest is the same. So here you see, XPath. It's like, hey, this plugin says, well, XPath is not recommended, so it scans it for that. Here you see a hard sleep. And I think here is a really good example of how linter can really help you to see, hey, this is never going to work. So here you see an example of using the Actions API. And well, if you use the Actions API and you don't use a perform, so .perform, it's not going to do anything, right? So this is without running your test code, without doing anything. You're just typing it in, and you get the feedback already. I think this is a really powerful rule. Let's see. Yep. Let's jump back to the presentation. Some key takeaways. So enable linter for code conventions, right, to increase the collaboration with developers, really talking the same language. You can get early feedback on test code while you're writing it. Try to use the same rules that you're using for application code as for test code. You can override certain rules for test code or vice versa. I showed you a couple of tools. There are many more tools out there, and one tool is not better than the other. So really choose what fits your environment. And we as a community, because I just started to play around with SonarQube because it solved a specific problem for me. But we as a community have much more experience than me and Alexander, so we could come up with much more intelligent linting rules. So we should extend this and have more these kind of dev tools as you also have when you are writing an application for test code, because I believe test code is a critical part of the software development lifecycle and should be treated as production code. That's it. Thank you.